Hello bachcho, how are you? Hi, hello everyone. Very good morning to one and all. This is your Vignesh. Welcome to my YouTube channel, Mr. Vignesh Tutorials. So I hope you all enjoyed my sessions, whichever videos I uploaded in the last classes. So today we are going to discuss our new session in our topic of M1 Mathematics Engineering. That is like till now I have explained you in screen itself, right? I recorded my screen and then itself I explained you. Now I am going to explain you about matrix on the board, because on screen it space won't be sufficient, so I am explaining on the board. If at all any difficulty in board or screen, you please mention to me in comment box. I will clear that problem. Okay, so without any delay, let's start our session. Okay, yeah, so this is session for M1 Maths for engineering students only, okay? And today we are going to discuss about rank of a matrix. Date is 8th of September. Today is 8th of September, okay? So we are going to discuss about rank of matrix. In our previous class, what are the topics we discovered? I can tell you. That is skew symmetric, symmetric, Hermitian and skew Hermitian. These all we discussed in the last class. In this class we are going to discuss the rank. In previous classes we discussed the different types of matrices like scalar matrix, unit matrix, identity matrix, etc, etc. Okay. So here in this session the rank of matrix is, first let us start with the definition. We know any matrix. Let's say some matrix, there is some matrix 3 by 3 matrix. Let's say the values are 1 2 0 4 5 minus 3 2 1, let's say 2 1 and 3. Okay, let's take some random example. Just I have taken some small values only, it's okay. Like not a much difficulty here. We have to find the rank of it. Before telling you what is the rank of it, I want to explain you a small definition called as determinant of a rank. Determinant of a matrix. Before telling you what is meant by rank of a matrix, I want to tell you a small topic called determinant of a matrix. Determinant of a matrix, that is denoted by delta, or you can tell D of matrix, something, any kind. You depends on your textbook representation. Okay, that means you can calculate like this is your C1, C2, C3, right? And this is your R1, R2, R3, right? So to calculate determinant of this matrix, let this be matrix A. So det of A is equal to 1 into, first I am selecting a element in column 1 and I am closing completely first column and first row. Whatever elements are there in this box, that I will multiply. Determinant of 5 minus 3, 1 and 3. For any 2 by 2 matrix A, B, C, D, if any matrix like this, determinant value is nothing but AD minus BC. Have you got AD minus BC? First select A into, close these two, D, whatever nothing is there, so D minus 0 minus of, make sure you have to select this B. Minus, why you are keeping minus means for odd selections you will take it as positive. For even selections, this is column 1, so odd selection. Column 2, even selection you will take it as negative again, so sign will be varying, so into C. So you will get AD minus BC. Same thing will apply here. So this is 1 into AD minus BC, 15 minus of, minus 3 into 1 is minus 3. Okay, so that is equal to 15 plus 3 is equal to 18. So this is not the total determinant of A. Okay, plus same way with 2 also you have to do. 2 into determinant of, these 2 you have to close, and 4 2 3 minus 3 you have to take. Data of that is nothing but plus 2 into 12 minus of minus into 6. That is nothing but yeah, this is explanation of this one. 18 plus whatever is here, 12 minus 6 is 6. 6 into 2 is 12 again. Plus, plus, plus. Again 0. With 0 is there, you cannot, don't need to do the whole calculation, because anyhow whatever the determinant inside is multiplied with 0. So it becomes 0 anyhow. Okay. So plus 0 you can give. That's why I have taken one 0 value to get an easier determinant value. So if you add 18 plus 12, it is equal to 30. So determinant value is 30. So det of A matrix is 30. That means for a 3 by 3 matrix you have to do determinant value like this. For 2 by 2 you have to do like this. Now going to matrix again to define what is a rank. Before telling you what is a rank, I want you to be clear with this determinant, and please take a screenshot of it. Okay. Now I'll tell you what do you mean by rank. Rank is nothing but if a 3 by 3 matrix is there, for example matrix A, okay, if the det of A 3 by 3 matrix, det value for 3 by 3 matrix is not equal to 0, implies rank is 3. If it is equal to 0, you have to check for determinant matrix of 2 by 2. Inside that you have to check for every 2 by 2. That means for this 2 by 2, for this 2 by 2, for this one, for this one, for this, like that. You have to take every consecutive 2 by 2 matrix and check that. If all matrices, in any of the matrices, like all of the matrices determinant value not equal to 0, then there the rank is equal to 2. Otherwise, if it is 0, check for 1. If that is also 0, then if that is then rank equal to 1, that is not equal to 0 means if it is equal to 0, generally we won't get 0, because for a unit matrix there won't be rank equal to 0, because unless and until every term of the matrix should be 0. Only for null matrix the rank would be 0. Okay. Now I am telling you how to know whether the rank of a matrix is 3, 2 or 1, so on. But I didn't define the rank of a matrix still. Rank of a matrix is the number of non-zero elements in a row for a matrix is called rank of a matrix. The number of rows has non-zero elements is called rank of a matrix. In a matrix, the number of rows which has non-zero elements is called, that means not in a normal matrix, in a what you can say normal form of matrix or echelon form of matrix. Echelon form. There are two forms, echelon form and normal form, that we'll be discussing in our further classes. So as far as now, one thing is to determine the determinant value and check the rank of a matrix, and other thing is to know whether the number of non-zero rows are 3, 2 or 1, and get the rank of matrix by converting it into echelon form or normal form. These two forms I will be telling later. First you understand, when you are converting into echelon form or normal form, it's a type of form of matrix. That means you are going to operate that matrix under certain operations, like columns are interchanged or rows are interchanged or operated plus or minus something into, and you are making into a simplified form of a matrix, and there, which is the simplest form, in that if the number of non-zero elements, here in this matrix directly you can tell number of non-zero elements are 3, so rank is 3. We got 3 in determinant determinant method also, but if you simplify, here you may get 3 non-zero elements in all the 3 rows, but if it is if it is reduced, if some matrix is reduced after reduced form, not this one, some example, some B matrix, if it is reduced, if it is 1, 2, 0, 2, 1, 2, 0, 0 and 0, 0, 0, if the matrix is in such form, this is the 0 row, yes, because all the elements are 0. It is a non-zero row, it is a non-zero. So two non-zero elements are there. So two non-zero rows are there with non-zero elements. So these two is nothing but rank of this matrix. If this is simplified form, of course it is a simplified form. You cannot simplify further and get any values like that. So it is a definitely yes. It's a non-zero rows 2. So rank of matrix is 2. So now I am going to tell you how to convert into echelon form and then normal form, how to find the rank of a matrix depending on those. So as far as now, understand the determinant type of matrix and finding the rank of matrix and this definition method. Okay, please take a screenshot of it. Any kind of doubt you mention in the comment box, I will solve it. Okay, I hope this is clear to you all. Now let's talk about echelon form of matrix. Echelon form of matrix to get rank of a matrix. Okay, we are finding echelon form of matrix to get rank of a matrix. Now let's take an example. 1 2 3 2 1 5 6 4 and -3. Let's take some random numbers. I have taken some random numbers, and for my convenience, I'll take one of the number as 0. Why not 6? I'll take here 0. Okay. For my calculation easy. Okay. I'm not taking this matrix from any kind of book or something for insert form, but randomly I have taken. But I'm taking some smaller value like 0 to make it easier. Now let's see. This is C1. This is C2. This is C3. And R1, R2, R3. Okay, we have to make some operations such that to make zeros in rightmost side. Like you have to be getting, you have to get lot of number of zeros. That means as more number of zeros are possible, you have to made into such manipulations. Okay, let's see. Now what I do, I'll operate between R1 and R2. Okay, R2 I'll operate such that R2 implies R2 minus 2R1. I'll take R2 implies R2 minus 2R1. Okay, that implies, so your 1 2 3 remain same and 0 4 minus 3 also will remain same. So your R2, 2 minus 2 times of 1 is 0, and 1 minus 2 times of 2, 4 minus 3, and 5 minus 2 times of 3, 6 minus 1. So this is the thing you got. Now see, I got 2 zeros and I want further zeros again. Now what to do? Now, if I add both R1 and R2 and R3, what can I get? If I add in R2 place, I will get 4 minus of 3. That means I get 1. In here, this place will get minus 1 minus 3 will get us minus 4. So, is there any use? Yes, let's see. We'll do that operation. R2 implies again R2 plus R3. So that implies, R2 implies, so 1 2 3 no change, 0 4 minus 3 also no change, and this if you add 0 plus 0 0, minus 3 plus 4 it is 1, minus 1 minus 3 is minus 4. So we got like this. Now what to do? Now I will subtract R1 minus R2 implies R1 implies, let's subtract these two. 0, 1 minus 4, 0, 4 minus 3, these are same. Okay, 1 minus 0 is 1 only, 2 minus 1 is 1, 3 minus of minus 4, it is 7. Okay, now if you observe this R1 and R2, if I subtract now R1 minus R2, or here only R1 minus 2 R2 I can take directly without going for these two steps. So this becomes 0. 1 minus 2 times of 0 is also 1 only. 3 minus 2 times of 4. 3 plus 8 is 11. So this is going to be 11. Are you following or not? I am going for R1 minus 2 R2. This is going to be my 11. Okay. Now see. Now what to do? I will interchange C1 and C3. If I interchange, I will get 11 minus 4 minus 3. And I will get here 0, 1, 4, 1, 0, 0. I will get this. Yes? Now I want to make this term also 0. Okay? I want to make this term also 0. How to make? If I take R3 implies R3 minus 4 R2, can I take? Okay, that implies, so here our R2 implies, so 0, 1, C, minus 3, 4, 0, C, minus, now R3 implies R3 minus 4 R2, so row 2 is same, is fixed, but row 3 you have to change. 0 is not going to change because R2 and R3 both are zeros. So, and 4 minus of 4, this is going to be 0. And minus 3 minus of 4 times of minus 4. R3 minus 3 minus 4 times of R2 minus 4. So, minus 3 plus 16, that is 16 minus 3 is 13. So, we'll get 13. Now, I converted almost all, but some more are left over. Now let's see how to solve those. Now, if I subtract minus 4 if I do C1 implies C1 minus C1 plus 4 C2. If I take C1 implies, this is C1, right? C1 plus 4 C2. My C2 and C3 are not going to be changed. C1 minus 4 times of 0 is nothing but again 11 only, here also 13 only. But minus 4 plus 4 times 1, this is going to be 0. Now you got these many zeros. Now can you change further? If I divide R1 by 11, it's going to become 1. it's going to be 1 by 11. And if I divide R3 by 13, it's going to become 1. It's going to be 0 only, no change. So if you see these two, if I subtract R1 minus R3 now, I'll get 0 1 0 1 0 0. This is same. And here if I subtract 1 minus 0 is 1 minus 1 is 0. Again this is 0. This is 1 by 11 as it is. Okay. So I got this kind of things. Now I'll change C1 implies C3. I'll do. So 1 by 11, 0 0 and 0 1 0 and 0 0 1. I got some scalar type of matrix, right? Maybe some diagonal matrix, right? But again if I multiply with 11, I can get here 11 0 0. Okay, this kind of value I am getting. Can I simplify it further? You tell me. Can I simplify it further? No, I can't, right? With any kind of operations if I do also, they can't be simplified further. Like if I divide with 11 again, it can become again 1, again zeros only. It's a unit matrix, you get a unit matrix. But here the rank is 3. So at most, the most simplified form also you are getting the rank is 3 because you are getting all 3 non-zero rows only. So this is the answer for this is the echelon form. This is the easiest echelon form. That means the most efficient echelon form, the most simplest form of having maximum number of zeros. So here you can find non-zero rows that is equal to 3. So here also one non-zero term is there and here also one non-zero term is there. Everywhere no non-zero term is there. So it is an echelon form and rank is equal to 3. So now next let us discuss another problem in which you have rank 2 and then rank 1 like that, so on. Okay, now take a screenshot of it. Okay, now I hope you understood this one. Now let us discuss one more example whose rank is 2. Same in echelon format only, I am not going to change the form. Problem number 2, matrix A, 3 by 3 matrix only, 1 1 minus 1 and 2 minus 3 4, 3 minus 2 3, 2 minus 3 4, 3 minus 2 3. Hope it's correct. Yes, it's a 3 by 3 matrix. You have to find the rank of it. Now normally we'll go with first step. R2 implies R2 minus 2 R1. Why? Because this is 2 times of this one, no? So I'm going to do that. 1 1 minus 1, 3 minus 2 3. I'm going to change R2, so this becomes 0. Minus 3 minus 2, this is going to be minus 5. 4 plus 1 is going to be 5. Sorry, 4 plus 2, right, is going to be 6. So this is my first point. And then R3 implies R3 minus 3 R1. R3 implies R3 minus 3 R1. With respect to this first term only, you do both the operations. So you get 1 1 minus 1. 0 minus 5, 6, this term. 3 minus 3 is 0, minus 2 minus 3 is minus 5, 3 plus 3 is 6. So you can observe R2 and R3 both are same. Either you can do R2 minus R3 or R3 minus R2, your wish. So 1, 1 minus 1, 0, 0, 0, 0 minus 5, 6. You cannot simplify further because you cannot take any values. This is the most simplest form and echelon form. Here the number of non-zero rows are, this is a non-zero row and this is not a non-zero row because all are zeros. This is a non-zero row. So the rank equal to 2. Rank of matrix equal to 2. Please take a screenshot of this very classic example. So within 3 steps you are going to get the echelon form and determine the rank of the matrix. Okay. So with such manipulations you can make it to rank of 1. That means you can get non-zero elements as only one non-zero row and other 2 are same. Okay, so you can get such kind of things, like if you have all the 3 multiples like this, 1, 2, 3 and 2, 4, 6 and 3, 6, 9, so on like this. Now you can do R2 minus 2R1 and R3 implies R2 minus 2R1, R3 implies R3 minus 3R1. So you will get 0, 0, 0, 0, 0, 0. You will get 1, 2, 3. So here it is rank 1 directly. And we'll do 1. Only one non-zero row. So such kind of examples are very pretty easy. You can always find them. So okay, now let us discuss what do you mean by echelon form of matrix or no, echelon form of matrix. Now let us discuss normal form of a matrix. Normal form. What do you mean by normal form of a matrix? A normal form of a matrix consists of, now let's say A is a matrix 3 by 3. Now in that some 2 by 2 matrix will be there. Yes? There is a 2 by 2 matrix, right? Like if this is identity matrix, if a matrix has identity matrix in it and other elements are 0, 0, 0, so on, if it may be any number of things, so that form is called as normal form. If a matrix after reduction or after some manipulations with columns and rows, if it has some identity matrix in it and remaining are zeros, then such matrix is called as normal form of a matrix. We are going to deal with this. So let us solve one example. Our matrix is 0, 1, 2, minus 2, 0, 1, 2, minus 2. It is a 3 by 4 matrix, students, and 4, 0, 2, 6. Then we are going to have 2, 1, 3, 1. So you can have one identity matrix in this after reduction. Let's see how it's going to happen. Now first our step is to make some manipulations. Let us do C1 minus C1 and C2, let's interchange it. C1 interchange with C2 implies we get this matrix 1, 0, 1, 0, 4, 2, 2, 2, 3, minus 2, 6 and 1. Why have I done this? If I do such kind of things, I'll get 1 here, I'll get 2 zeros here. It is near equivalent to my identity matrix. I'm converting this into my identity matrix. So now let's see next what to do. Then if I take R3 minus R1, it becomes 0 in my R3. Here this is R3, right? If I subtract this one, R3 implies R3 minus R1. If I do, I'll get 1 minus 1 is 0, 2 minus 0 is 2, 3 minus 2 is 1, 1 minus of minus 2 is 3. So I'll get this form. Now if I make R2 by 2, if I divide, I'll get again some better values. If I make this R2 by 2, it will become 1, 0, 2 minus 2, 0, 2, 1, 3 and 0, 2, 1, 3. See, you can multiply and divide particular individual row, there is nothing harm in that. Okay. And if I take R3 implies R3 minus R2 now, R3 implies R3 minus R2. Both are same, right? If I take this, R3 implies R3 minus R2. What do I get here? 0, 0, 0, 0. I get 0, 2, 1, 3. I get 1, 0, 2 minus 2. Now, we got such format now. Now if I divide again by 2, or if I interchange C3 with C3 minus 2C1, C3 minus 2C1, this is C3, this is C1. If I undergo C3 minus 2C1, what do I get? My matrix will be like 1, 0, 0, 0, 2, 0, minus 2, 3, 0. All other 3 columns, C1, C2, C4 I am writing as this. This one minus 2 times of this one is 0. This one minus 2 times of this one is 1. This becomes 0 as this. So, I will be getting nearly a unit matrix kind of thing. Now, if I make C2, C3, C4, if I divide this one, here C2 by 2 if I do, it becomes 1. So, I may get a unit matrix here, but thing is the 1 is here. So what to do now? Just think of it. Now if I change, you can see these two rows, C4 minus C2. C4 implies C4 minus C2. If I take here this matrix, C4 implies C4 minus C2. Let this 2 be as this 2, not dividing here. Okay, sorry. Let this 2 be as this. If I do this, I'll be getting 1, 0, 0, 0, 2, 0, 0, 1, 0. This becomes C4 minus 2 times, right? Becomes minus 2. This becomes 1. This becomes 0. So now, if you observe clearly, if I divide this one by 2 now, it becomes 1. So these two rows are similar, right? So what I can do? I can subtract C2 minus C3, or I can take C3 implies C3 minus C2, and I will interchange. Then I am writing here. Next step I am writing here. Please don't get confused. I will write here. So it will become 1, 0, 0, 0, 1, 0, and if I subtract these two, it becomes 0, 0, 0, and minus 2, 1, 0. Okay. And if I do this C4 plus 2 times of C1, if I add, again I will be getting 1, 0, 0, 0, 1, 0, 0, 0, 0, and here also I will get 0, 1, 0. Again these two are same, no? We can eliminate 1, this becomes 0. So finally I get 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0. So I will get some unit matrix here. Very smallest unit matrix. I will be getting I2 with my remaining zeros. I will be getting this one. So that's my final matrix obtained, and that is our normal form. I can clearly say that this is my normal form, NF. So I hope you understood clearly. First we are doing C1 and C2 interchange, then R3 implies R3 minus R1, then R2 by 2, then R3 implies R3 minus R2, you are getting this. Then you are undergoing C3 minus 2C1, you are getting this, and from there you are doing C4 implies C4 minus C2, you are getting this. Then here you are doing C3 implies 2C3 minus C2, you are getting this one. And then here it's a very basic calculation, subtracting the columns and getting the I2. So it's very simple, students, just small manipulations according to max, like you have to operate between rows and columns. If you keep practicing, you'll get this. If you have any kind of queries, you can ask me. I will explain it much more clearly in the next coming videos in the normal form. So please take a screenshot of it. Any kind of doubts, please mention in the comment box, and don't forget to share this video with your friends and help them out. Okay, please like my channel, comment it, share with your friends, subscribe, and click on the bell icon for further more updates. Okay, and this is your Vignesh signing off.